Okay, so we've spoken about some fluid balance concepts. We've gone over some electrolytes, uh, and now we're talking about the acid-base balance, the pH. Over time, you're going to see these all interrelate in terms of keeping the body in a very stable environment of pH, which is a measure of how acidic or how alkaline your blood is, um, a fine balance of electrolytes, and a fine balance of fluid, not overloaded and not dehydrated. So all of these things will start to make sense later on, as you see that they're really interrelated. So acid base, we measure how acidic something is or how basic something is with a pH scale. And typically your blood has a pH between 7.35 and 7.45. So if you're producing a lot of acids, the pH scale, it's not intuitive, but the pH scale will drop. So for example, a pH of 7 is acidotic. So as you're adding H+, you're actually dropping on the pH scale. So for example, battery acid would have a pH of 2 or 3. Stomach acid has a pH of around 3, which is amazing. It's incredibly powerful, stomach acid. And these are exponential drops. So the difference between a pH of 7 and 6 is a factor of 10. It's a big, big difference. It's not a tiny, just one number difference, okay? Going the other way, alkaline means you have less acid. You have less H+. Okay, so you're alkalotic. Definitely in the body, the most concerning condition is acidosis. The body is continually, because it's metabolizing and metabolizing sugars, making energy in the form of ATP, performing all the body functions to keep the body stable. It's constantly producing acids as byproduct. So if you were to get sick or something goes wrong in the body, say you get a pneumonia, you typically become acidotic. It's not common to become alkalotic. We'll refer to a couple of conditions, but it's acidosis that we get really concerned about. So let's just say that anything below 7.35 is acidosis, and anything above 7.45 on the pH scale is alkalosis. If you look at the bottom of this slide, a pH of less than 6.8 usually is not compatible with life. So I've seen a couple hovering a bit below that, but 6.8, all the metabolic processes in your body come to a halt. They just can't function within an acidic environment. And the other way, a pH of 7.8, so alkalotic, is not compatible with life either. So on to the next slide, acid-base balances. If you can think of all your body's functions, the metabolism of glucose, the breakdown of fats to produce energy and proteins, all of these processes are constantly producing H+ acid in your cells that then get out into the bloodstream, the serum. And this is one of the tightest controlled parameters in the body, your pH, because as soon as you leave normal pH, processes in the body stop performing optimally. So the body has buffering systems to protect against changes in the pH. So there's bases. So there's chemicals in the blood that if you start to produce too much acid, they can buffer, they can combine with the acid and neutralize it. So those are called bases, or basic chemicals, bases. And we'll get into that in a minute. So bicarbonate is a neutralizing base for the acids in your blood. Acids can also be excreted by the kidney. So H+, the kidney can secrete acids to maintain a normal pH. So, and also the kidney is the main producer of bicarbonate in the blood. So you can imagine if the kidneys start to fail, not only can they not clear the acids, but they stop producing bicarbonate. So renal patients or renal failure patients can develop metabolic acidosis. So any process that's happening within the body that produces acids or bases, we would call metabolic. So within the body, it's a metabolic process, metabolic acidosis, or metabolic alkalosis if it happens to be producing too much bicarbonate. So we see the kidneys are going to be they're going to be involved in getting rid of acid and also producing bicarbonate to buffer all the acid that's in the bloodstream. The pH scale we've spoken about. It's a measurement of hydrogen ions. I wouldn't worry about this term too much. Negative logarithmic scale. Basically, it's a factor of 10 when it drops from 7 to 6 to 5. So huge. So one number changes, but huge changes in the pH. Okay, so let's talk about the first buffering system in the bloodstream. Okay, and when we're talking about buffering systems, some work much faster than others, right? So the one we're going to talk about now is a very fast-acting buffering system for acidosis, because the body does not want to live in an abnormal pH environment, okay, whether it's acidosis or alkalosis. But remember, the much more common one and the much more dangerous one is acidosis, since your body is continually in a state of breaking down acids and metabolic processes that are producing acids. Okay, so this buffering system is an immediate response. So let's look at this reaction, and I think it'll start to make sense. So let's look at the right side. So H+ is acid. So if you start to build up acid in your bloodstream, it'll combine with bicarbonate, which is a buffering molecule, and it'll go all the way to the left and become H2O and CO2. And we're going to talk about this one in the next example of buffering systems, which will be the respiratory system. But CO2, you can just breathe off, right? So in the bloodstream, the acid can immediately be converted with bicarbonate to H2O and CO2. Okay, so that's important because the body's going to do everything it can to keep the pH between 7.35 and 7.45. Okay, so what else can the serum do? So as H+ increases, meaning acidosis, there's a system where cells can trade off an H+. They will take an H+ into the cell, and they will secrete a potassium molecule, K+. Okay, so there's an exchange. It's called the potassium hydrogen exchange. And this is a way of hiding H plus in the cells. Okay, and that allows the system to maintain normal pH in the bloodstream. Okay, so you can imagine if someone is very acidotic, one of the first systems to take place is this reaction in the bloodstream where H plus reacts with bicarbonate to make H2O and CO2. Okay, so getting rid of some of that H plus is going to stop the system from becoming acidotic. But also H plus can go into cells as long as the cell secretes a potassium. And why does it have to do that? To maintain electrical neutrality when it's trading, right? So it's taking a cation in, H plus, and it's removing a cation, K plus. Okay, so this cellular exchange is temporary. Okay, it's going to allow the body to hide the H plus so that acidosis can be immediately controlled and dealt with. Okay, so the serum is the fastest acting buffer in the system. So let's talk about the next buffering system, which is the respiratory system, the lungs. And they're a very effective and quick response system to address increasing acids or decreasing pH in the bloodstream, in the serum. Now write down this equation again, because this is the one that's going to help you. H plus, which is acid, plus HCO3, which is bicarbonate, and you have that floating around in your blood, is in equilibrium, so equals H2O plus CO2. So if you produce too much H plus from some process in the body, you can see that it can shift to H2O and CO2. And if it shifts to CO2, the brain will tell the lungs, will stimulate the lungs to breathe faster. So it'll breathe faster, breathe deeper to blow off the CO2, which is in fact getting rid of H plus and maintaining pH. The opposite will happen if your CO2 drops. So say that your H plus is low, so you're actually alkalotic. Your pH is greater than 7.45 for whatever reason. Well, your CO2 is going to be low, and your brain will say there's no need for you to breathe fast or deeply. The CO2 is already on the low side. We don't have to blow off acids. So the other regulatory organ for maintaining pH is the kidney, and this is definitely, the kidney is the big organ to make sure that the pH is maintained in a normal range. It just takes a few days for it to really kick in. So it takes some time to make all the bicarbonate, the HCO3, to neutralize the H plus, the acids in the blood. It takes time to excrete more H plus. So it's not the initial, it's not the fast response that the switching with the potassium is, or the respiratory system that can breathe fast, but it's the huge response that can produce lots of bicarbonate and excrete lots of H plus when needed. So those are the two things that the kidney can do to maintain pH: make bicarbonate and filter and excrete acid. And you can see that if you have an acidotic state in your blood, which the body does not want to tolerate, you're going to start to make a lot of bicarbonate from your blood, from your kidneys to buffer it. Your lungs are going to do everything they can to blow off the CO2 to lower that H+. And there's going to be a constant trade-off with potassium. So all these processes are working together to maintain that pH. Your urine, if we checked it, would be definitely on the low side because you're getting rid of H+. So you might have a pH of 4 because the urine is getting rid of H+, excreting H+, making acidic urine. So let's do a question here, because I think questions will maybe clear up some potential confusion. So Anne is experiencing a disruption in her pH balance. So whenever I read this question, I think, okay, there's 3 systems involved to maintain pH. The ones with the cells that trade off with potassium, the system with the respiratory system to blow off CO2, and then that lowers H+, and the one with the kidneys that makes bicarbonate and can also excrete acid, H+. So which buffering system is the first to respond? Well, it's the plasma system, right? It's the serum that can trade off immediately with potassium and hide the H+ in the cells. Okay. Now this question doesn't say whether she's acidotic or alkalotic, but even if she's alkalotic, meaning her H+ is low in the serum, in the interstitial fluid, which is in equilibrium with the serum. Well, no problem, because you can still have H+ come out of the cells and potassium go into the cells, and that will lower the pH if you're alkalotic. So whether you're alkalotic or acidotic, the first system to respond is the plasma system. The renal system takes a day or two, so that's not the first system to respond. The respiratory system can respond quickly, but not as quickly as the plasma. And D just doesn't, it's not a system, it's not an answer. Okay, so let's just have a little review here of the buffering systems. Okay, so I'll give you an example. A patient comes in with pretty severe metabolic acidosis with a pH of 7.0. Okay, that's pretty significant. When you have a pH of 7.0, you're going to be sick. And the reason for this acidosis is because this person forgot to take their insulin, and they are now in a condition called metabolic acidosis or diabetic ketoacidosis. So we're going to concentrate on the low pH. Okay, so what does the body want to do with this low pH or high hydrogen atoms circulating in the bloodstream, causing acidosis? Well, it's going to do everything it can to get to 7.35 to 7.45. Not that it's always able to, but it's going to start these 3 systems so that they can maintain normal pH. And the first one and the fastest one is the serum buffering system, where hydrogen ions can react with bicarbonate to become H2O and CO2. Okay, remember that equation, right? Perfect. I've moved the H+ and combined it with bicarbonate. Okay, so that's taken place in the serum. I can also have H+ move into cells as long as the cells move potassium out. And that's why patients that are very acidotic have hyperkalemia. Okay, because all this acid is trying to move into cells, and the cells are saying, well, I'm going to have to move potassium into the bloodstream. and that's why they come in hyperkalemic as well. So that's basically the serum buffering system, right? H plus with bicarbonate moves to H2O and CO2, perfect. And H plus goes and hides into the cells temporarily. So really that's a temporary reaction, because hiding H plus in cells, well, at some point the H plus has to come out, okay? The respiratory system, well, the ability for the respiratory system for the lungs to breathe faster and deeper, to blow off more CO2. And if you blow off more CO2, you are essentially blowing off H plus. Because if you look at that equation, the H plus that combines with bicarbonate then becomes CO2 and H2O. Okay? And that's why patients that are acidotic, say for example, diabetic ketoacidosis or any metabolic acidosis, they're breathing fast and they're breathing deeply. Okay, so that's called Kussmaul breathing. Those deep breaths trying to blow off more CO2 to reduce the acidosis. And finally, the biggest regulator of acids or pH in the body is the kidney's ability to produce more bicarbonate, which will neutralize the H plus, and also the kidney's ability to secrete hydrogen ions into the urine. Okay, but they can take days to come into effect, right? The renal system. So there's a fast system, and then the respiratory system will kick in very quickly as well, and then the renal system would be third.